Combining trig functions and inverse trig functions, Part 1. You should be familiar with the 6 trig functions and inverse trig functions. In this lesson, we will find values when the two are combined. We will now try to find the exact value of expressions involving both ordinary trig functions, like sine and cosine, along with their inverses. Here's an example. Before we get into the specifics of finding the exact answer, we should first understand whether our final answer is going to be a number or an angle. The 1/2 is a number which represents the length of one side of a right triangle. And the inverse cosine function inside the parentheses asks you to find the angle whose cosine is 1/2. Therefore, the object inside the parentheses is an angle. You are then asked to find the sine of the angle, which will be a number. We can solve this problem directly. Using the unit circle, we know that pi over 3 is the angle whose cosine is 1/2, and that the sine of pi over 3 is the square root of 3 over 2. Here is a similar problem. Again, before trying to find the specific answer, it is important to understand which objects are angles and which are numbers. Again, in this problem, we begin with a number, which is the length of a side of a triangle. The inverse cosine function finds the angle, and then we are asked for the sine of the angle, which is a number, specifically the height of the triangle. Inside the parentheses, we have the angle whose cosine is 2/3. Using the unit circle won't help because we don't know the angle whose cosine is 2/3. However, we can find the value of sine of theta when we knew the value of cosine of theta using the trig version of the Pythagorean theorem. Here is the problem restated. We use the Pythagorean theorem and solve for the sine of theta. The sine value is the square root of 5 over 3. We picked the positive value because we are in the first quadrant. We can also do this problem by using the geometric definition to label the triangle, and use the Pythagorean theorem to find the value. Here's a similar problem. This time the cosine value is negative, but the lengths of sides of triangles can't be negative. We can still do this problem. The cosine values are negative in the second quadrant, so this is the same triangle as in the previous problem. You can label the sides of the triangle with positive lengths, and then recognize whether your final answer is positive or negative by noting which quadrant you are in. On the other hand, you may wish to include the negative side on the length of the sides of the triangle as a reminder. Here's an easy one. You begin with a number which is the sine of an angle. The angle is the object in parentheses. Specifically, the angle is the angle whose sine is 0.276. You are then asked to find the sine of that angle. We label the height of the triangle, and then are asked to find the height of the triangle, which is 0.276. Here's one in the opposite direction. We begin with the angle, find the sine of the angle to get a number, and then find the angle that has that number as its cosine. The sine of pi over 3 is the square root of 3 over 2, and the angle whose cosine is the square root of 3 over 2 is pi over 6. Working with the tangent function is not much more difficult. We can use the geometric definition to label a triangle and read off the appropriate value. Likewise, reading the tangent value from the triangle is not difficult. Secant, cosecant, and cotangent also require a little work. To do a secant problem, do the equivalent cosine problem first, then take the reciprocal. Similarly, if you are given information about the secant, cosecant, or cotangent, change it into information about the reciprocal function. To recap, inverse trig functions give information about the lengths of sides of a triangle from which you can label a triangle. The trig version of the Pythagorean theorem allows you to find the missing side. Values of the other trig functions can be read from the triangle.